Hi, everyone, and welcome to our Google Cloud Community event focused on embeddings for custom applications. If this is your first session with us, welcome. And if you've joined us before, welcome back. It's great to see you and have you here with us today. We would love to hear from you in the comments. If you have any questions or comments, we just love to see where you're tuning in from as well. My name is Lauren, and I'm the content manager for the Google Cloud Community. And I'm thrilled to be here today with Guru and Bala, who will be taking you through the content and answering your questions today. So if you do have any questions, those are encouraged. Please feel free to add them into the YouTube chat box, and we'll be sure to get to them either in the chat or at the end of the presentation. And for any questions that we don't get to, we encourage you to add those into the Google Cloud AI community forum, and that link is in the YouTube description. I'll also drop it into the chat so you can have it as a quick reference. All right, with that, I know we have a lot of awesome content to get through today, so I will hand it over to the team to take it away.
Thank you, Lauren, and welcome everybody for this wonderful discussion on embeddings. In the world of machine learning, embeddings serve as powerful translators, enabling us to unlock the hidden meaning within our data. So in our session today, we will be diving deep into what are embeddings, how can embeddings be used for building new applications. We'll get into what are some of the architecture behind it, the models and tools. We'll also look into some strategies for storage, indexing, search, and retrieval. And then later we'll do a demo and then move on to a Q&A. So welcome you all for an exciting session. I'll now turn it over to Bala to take us through our first couple of topics. Over to you, Bala.
Hello, everyone. Welcome to the session. We will start with what embeddings are, and we will follow the thread of thought here. We would see how embeddings are used in machine learning and what are some of the tools that you could use, and then how Google uses embedding and how to create them and how to integrate it with your applications. So think of embedding as an encoding tool. Right? So it will translate the words, queries, documents, images, and audio, and any other content to numerical vectors. So if you look at the numerical vectors, they don't have any meaning in isolation. Right? Once you take these numerical vectors and put it in the embedding space, then you are getting some meaning out of it. When you look at the embedding process by itself, what you are trying to do there is you are taking your high dimensional data and then mapping it to a low dimensional space. And this embedding space is basically where you will see the distance between the embeddings, talk about how similar they are or how dissimilar they are. So the embedding space has a boundary, and the boundary is typically defined by 768 or 1408, depending on the model that you use. And then the input that you give to this has a limitation as well in terms of how you would chunk and do your embeddings. So embeddings can be learned and reused across models. So from a concept perspective, there are three things that you got to remember, right? One is you create these embeddings, you look at your data, raw data, you create these embeddings, and you put them in the embedding space. And that gives you a way to see the distance between them and understand the vector similarity, and you give meaning to this embeddings. And then you basically can search this embedding to see similar content. On the right-hand side, what you see there is 8 million Stack Overflow questions. This is a public data set that we have. And you are visualizing the text embedded visualization using Nomic AI. So on the bottom there is a notebook. The notebook talks about how to use this public data set, how to do text embedding, and how you would visualize it. So if you want to explore more and try out, please click on that link and try it out. Now, let us look at multimodal embeddings, right? So text embedding, you are giving in the text, and then you are creating the embedding vectors, and you're putting in the embedding space. In terms of multimodal embeddings, you're going to place text, images, videos, etc. in the same embedding space. So you are looking at images, you're looking at video, you're looking at a short clip from YouTube there, and then you're having a text that's a query and snippets. And what you have done here is, if you look at the multimodal embedding space in the center, you're placing the embeddings in this space in such a way that similar content is grouped together, right? So if you are looking at a dog, and you're looking at a dog with a sports car in the background, see how they are kind of close to each other, versus when you are looking at a kitten there and looking at a image of a car on the right hand side, right? So you can take any kind of content, and then when you create the embedding and when you put it in this embedding space, you are going to figure out how similar they are based on the vector similarity. So there are a number of use cases here for multimodal embeddings. You could do image and video search. So you could give a picture, and you could search on that image and find all relevant content to that. You can search video. You can do rankings and recommendations. You can do image and video classification, perform a zero-shot classification of an input image or video. You can do content moderation. You can identify images, video, text that has been considered inappropriate. And you can there are so many other use cases here that multimodal embeddings can enable. Now, where are these embeddings used, right? So how do we use them? So these embeddings are commonly used for recommendation systems, semantic search, image search, chatbots and question answering, fraud detection and outlier detection, classification, clustering, and improving accuracy of the LLMs. So the most common one is a recommendation system, right? So you have a product, somebody comes and gives an image and says, like, do you have a product? Can you recommend a product for me, right? So you can search on the image, you can search with the text, you can answer a natural language question. So you're creating a interactive experience for the user, where they are coming in and doing a natural language question or an image and asking you for recommendations on the product that you have, or it might be any other thing, right? Looking at semantic search, looking at Google search, right? So if you want to understand the intent, and if you want to understand the similarity, and you wanted to search on a particular topic, right? Typically what we do in search systems is we would use a keyword search. Having a big repository and doing a keyword search can take hours and hours to get relevant information, right? When you look at semantic search, you are going to look at how similar the content is, and you're basically going to combine. You're going to search for the embedding vectors, and you're basically going to rank them, and you're going to give that as an output, right? Then you could do image search. We came out with a circle to search option recently, right? So you can have your mobile phone, you can circle something, or you could bring a Google Lens and point at something, and you could search using that image, right? That image might be a product, that image might be an object that you want to know more about. So search, you can do search with image as a starting point. And then chatbots and question answering systems. These are more common use cases that you would see. So think of any application that you have, and you want to give that capability to chat with you, right? Maybe they're chatting with you to get a recommendation from you, or they're chatting with you to know more about your products, or they are chatting with you to solve a problem, right? So chatbots or embeddings will provide chatbots with real-time information, and can provide chatbots with your information, which is stored inside of your organization, and can help ground LLMs if you're using LLMs as part of the chatbots, right? Uh, Fraud detection. I mean, if you're in the financial world, people are accessing, your financial systems, and you want to take these transactions and identify a pattern, right? The more patterns you identify, you will know whether it is a normal pattern or it is an anomaly that you got to detect. And you can use embeddings effectively to do fraud detection. At classification clustering, it's much more more prevalent AI use case. And then you are looking at improving the accuracy of the LLMs, right? So there are a number of endemic problems that can be solved using embeddings when it comes to Gen AI, right? Um, so how do you reduce hallucinations, right? You can ground it with information, with facts. So you can ground it with information that you have within your organization. So you improve the accuracy of what the LLM predicts, or the LLM gives us a output. Uh, you're looking at your intellectual property and you want to keep it within your organization. You don't want to train the LLM with your content. So in this case, you want to leverage the power of the foundation models, but you don't want to train the foundation models with your domain knowledge. So embeddings are going to help you by creating a local embedding store and then providing the context to the LLMs when you want to when you want to use the power of the foundation models, right? Uh, it is going to help you avoid manual process related to prompt engineering. So nowadays, you don't have to create a prompt; you can programmatically do it. So you create a template, and you can use embeddings to find the right things to fill in that template and provide that template as a context to your LLM and kind of get your predictions from the LLM. Right? It can also serve as a long-term memory for more complex use cases. What we are talking about here is this is a rapidly evolving field, right? So if you are doing chat and you have a long chat history, and a customer is coming and asking you, hey, how do you how do, I saw this problem. Is it a bug, or have you seen this with my history before, with all the chat that I have before with you, right? So you kind of provide this long-term memory to your LLMs. So it kind of gives a context. At the same time, it also summarizes what has happened with that particular customer in terms of the personalization, and then you could use your embeddings to provide the answers and chat with your customer and support more effectively. So how do we think about embeddings in the machine learning world? So the first part is the data part, right? So you take all kinds of content that you have images, speech, music. You take all the raw data that you have, and your raw data is going to have millions and millions of dimensions. You want to take that and you want to put it in the embedding space, and you want to reduce the dimensionality. So the more number of dimensions you have, you're going to have the semantic relationship. You're going to have much more rich semantic relationship. But at the same time, you are going to, the more number of dimensions, you're going to make it much more slower in terms of getting responses, right? So your data is typically stored in your operational data store, and you have an object store or a relational database, non-relational, NoSQL databases, graph database, hierarchical database, whatever you have where you store your data. What is happening in this side of the house is the databases, it might be SQL or NoSQL, or coming out with native capabilities to have embeddings stored in them. And they also are giving the capability to search your embeddings, do vector searches using traditional SQL and traditional programming APIs, right? On the DL models, you're going to have, you can use any kind of model. You can build a custom model. You can have an open source embedding model as your starting point and build your models, or you can use a third-party model and you can fine-tune it, right? So on the Google Cloud, you're going to see you are going to use the Vertex AI as a unified development platform to do all of these, right? So Model Garden, which is part of the Vertex AI platform, is going to give you the capability to click and use the open source models, the foundational models from Google, your custom models or third-party models, right? And then if you look at the embedding space, there are a couple of things that you will see here. It has a fixed dimension, right? So you can take any kind of content. You can take an image, you can take a text, you can bring in all kinds of unstructured data and structured data together, and then your output dimension is basically, it is fixed, so that every data point that you bring in has a fixed number of dimensions. So you place it in those dimensions, and then you get to see how they are related to each other when you put it in the embedding space, right? So this is encoding meaningful semantic information into your embedding space. Now, on the left-hand side, there is a Google machine learning course, and then there is also an article on AI multi-tool vector embeddings, talking about, an article talking about what vector embeddings are and where they are used and how you would use them. Now, in the machine learning world, what you want to do is you want to come out with a model that is giving you accurate results. At the same time, is also reducing the latency in terms of searches. Right? So those two are very important, and that will kind of lead you to picking the right model and picking the right number of dimensions. Now, this is how Google organizes data across various services. So this is how Google search, YouTube, etc. searches and recommends relevant content. What you want to see here is on the left-hand side, you see the text embedding, and on the right-hand side, you see the image embedding. And in the business sense, the embeddings can be anything, right? Embeddings can be product, it can be users, it can be activities, dialogues, music, video, sensor signals, events, on and on and on, right? What you're trying to do is you are, if you're looking at products, you're taking all the products and you're putting in the embedding space so that similar products are grouped together, right? And when you search for them, you are kind of getting similar products, right? There is a link at the bottom here which talks about Vertex matching engine and how you can Vertex matching engine, and shows how you can use the matching engine to get blazing fast, massively scalable searches. And how do you get value out of your embeddings? We talked about multimodal data. We talked about structured and unstructured data. So you bring all your data and you feed it to your deep learning model, right? These are pre-trained custom encoders, right? What they're going to do is they're going to take all this raw data that you put in, and they're going to come out with these vectors of numbers representing the semantic structure of the entity, right? So once you get the vector representations, now you got to store it somewhere, and then you got to create an index on the top of it, and then you got to serve this index as an endpoint, right? So whenever your application is coming in, and whenever somebody is asking you a question, or you're building a Gemini application, you will use this serving index. You would take the question or the query that you are getting, and you would run through your embedding model. You will create a embedding vector, and then you will use that vector and search to see where that vector is in your embedding space, so that you can find similar things, and you will rank it and return it back. Now, how do we create these embeddings, right? Definitely, if you are going to use our Vertex AI platform, which is our unified developer platform, you can use Vertex AI embeddings API to create multimodal and text embeddings. Now, there are a lot of libraries and advanced methods that are available. So if you go to our model garden, most of them are available, where you can just click and use the model. And you can build your end-to-end flow using these models, right? And then if you are thinking about a strategy on how to create these embeddings, right? On the right-hand side, there is an example. So in the example, your goal is to recommend a movie based on the movies that the user has previously seen, right? So you have the art cover there, and you have the title of the movie, you have the rating, you have the genre, and then you have a description of what the movie is, right? So we can take each of these individual items, and then you can do a image embedding, you can do text embedding, you can kind of summarize your long string and identify um, the principal components of the storyline. And then you can use all this and feed it to your model, maybe a custom model that you created, right? And then you can create a movie embedding, right? So you can store all these as separate embeddings, or you can bring all that in and store it as one movie embedding, right? So how do you decide on what you would do? It is basically like, tell me what your use case is. Is in the standard database world. How do you store your data, and how do you retrieve it, right? If we know how we are going to retrieve it, then we would say, like, what kind of strategy that you would use. Now I'm going to talk about integrating embeddings with your applications, right? So we talked about what embeddings are. We talked about the use cases for the embeddings and how it applies to the machine learning. And then we saw how Google is using it. And then we saw how we will create the embeddings. Now, let us see how we can integrate it with our applications. Now, the idea here is you are basically orchestrating interactions between your applications, database, and AI models. So on the picture there, what you see is you see a Gen AI application. It can be any application, not specifically a Gen AI application, right? Um, so you want your application to interact with the embedding models, the LLMs, and your operational databases, right? So if you look at your operational databases, these are the backing stores for systems of engagement, right? Your mobile web apps. And if you look at the LLMs, you have a lot of foundational models. They are trained on Internet Corpora, and they can, predict the words that are most likely to follow a given prompt, right? And then you have your embedding models. These are basically vectors. Probably you are generating these embeddings and having a local embedding store that you want to integrate your application with, right? Here are some of the orchestration use cases. So I have highlighted 3. Of course, as developers, you can come out with a variety of ways to do this, and there are lots and lots of combinations that you could have, right? So the first pattern, the first use case is basically using the embedding models, not using your LLMs. So you're going to use the embedding models, you're going to use your operational stores, and you're going to have your applications kind of look at what you have in terms of embeddings and answer a user question. And on the second pattern that you see there, you're going to use your LLMs. Here, you're not going to use your embedding models, but you're going to use your LLMs. But you want to ground your LLMs with facts so that you can give real-time data and you can ground it with facts so that you are getting accurate results. And the third pattern that you see there is a combination of everything, right? You want to use your embedding model, you want to use your LLMs, and you want to use your operation databases, right? So commonly, there are 2 patterns that you use with your applications and how you integrate with your applications, right? On the left-hand side, what you see is you have data sources. Now, think of data sources as any application that you have and any data store that you have that you want to use to enable capabilities, Gen AI capabilities for your applications. So from a question perspective, somebody is trying to get information, right? So show me a shirt matching the color of my cat, right? In this case, you can do it through an image and say, like, hey, here's an image, show me something like this. Or you can have a natural language query come in, right? First thing you would do is you would take that query, you would take that question, and you would pass it to the embedding model, and you will get your vectors, embedding vectors, right? And then you will do a similarity search. So you will do a vector search, and you will return the relevant results from your embedding database. And then you will use that as a context and provide that to the LLM, and then the LLM is going to give you the output. right? So here are the red shirts that you might like to purchase, and then it's going to show you the output, right? So this is a very, very common pattern. On the right-hand side, what you see is you see a RAG pattern, right? A retrieval augmented generation pattern. So you have an input prompt come in, and then you have a retriever, which is going to send the question and look at the external knowledge it has, and it's going to bring in related context, and then pass that context. After you rank the results, you pass that context to the generator, and the generator is going to generate the answer for you. So these are two common patterns that is used with applications. And at the bottom, there is a link that shows a repo where you could look at GenAI databases retrieval app and see how it works. And I'm going to pass it on to Guru to talk about metrics, tools, models, and architecture, and storage, indexing, and retrieval. And then he will walk you through a demo of whatever we have seen as concepts from embedding and how you use embeddings. Guru, to you.
Thank you, Bala. Thank you for that wonderful presentation. And talking about orchestration of applications using embeddings in LLM, what I will focus more on is really around operationalizing that. And I'll be touching upon metrics, tools, models, and architecture, as well as going to some of the storage strategies, indexing strategies as well. First, I want to start off with Vertex AI. One of the things that a fun fact here is, if you look at success in machine learning projects, only 85% of the projects usually don't get into production. And the reasons why we have such a low success metric in machine learning projects is because many of those projects just stay experimental. And part of the reason is because we do not have the tools for us to deploy it into a production environment. We do not have the tools to monitor a machine learning application. We do not have the tools to monitor the training set in queue. We don't store these models in a registry, or we have to reinvent some of the things that we have done before. So that really brings down the business case, the value that a machine learning model could deliver. And that's one of the reasons why many of the machine learning projects just stay in the experimental stage. And that is where I want to urge you all to look deep into some of the tools that we have in the Vertex AI platform. Whether it is your data warehouse that can store your data, or your solutions like matching engine that can serve as a very powerful vector store, or even some of the various pipeline and model tuning tools that we have. So I would certainly encourage all of you to take a look at the tools here and think about an end-to-end application as we think about operationalizing. And as we continue this journey of how do we operationalize and expand the user experience for our users, I want to touch upon some of the models that we have available. For a text-based application, whether it is your text classification, question and answer, or retrieval augmented generation, we have the text embedding gecko. The text embedding gecko is a world-class model available on Vertex AI, and it can handle up to 3072 tokens per input field, and up to 5 inputs per request. It can go up to 600 requests per minute, and it's definitely an important tool that you want to consider for your applications. Multimodal embedding at 001, that's the multimodal side of the house. And whether it is image classification, search, recommendations, I would encourage you to take a look at multimodal embedding at 001. It's a powerful multimodal tool, and we'll also be doing a demo on that as well. And besides these Vertex AI models, we also have a number of BigQuery models as well, like BERT, Neural Network Language Model, or the open source Wibble, are all available on BigQuery. And they all publish vectors of different dimensions. And the BERT model, you could invoke it remotely from Vertex AI, whereas the NNLM and Swivel model, you can import it through TensorFlow. Besides these models on both Vertex AI and BigQuery, you have a whole host of open source models, and those models can also be invoked both through Vertex AI and BigQuery as well, and they are available on Model Garden. So I encourage you to take a look at it and see how you can incorporate and build some world-class applications. I think Bala touched on this briefly, and he talked about some of the challenges that we have, as we are orchestrating these applications, whether LLMs plus embeddings or pure embeddings or pure LLM. Then there are some metrics that we can use to measure how we are delivering these applications. Whether at the user level or whether at the model level. So if you can look at it the model level, you can measure the performance of the model. For example, if you're looking at a classification model, then we have metrics like micro F1, macro F1, per class F1. These metrics are available, and some of these metrics can be directly generated using the Vertex AI SDK. Or if you're launching a question and answering session bot or retrieval augmented generation, you can use metrics like the exact match. And if you're looking at an end-to-end application level, the application, there is a piece that is retrieval, there is a piece that is generation. On the retrieval stage, there are metrics that we can use to measure, for example, from the pure retrieval side as well as the ranking. There are metrics like precision and recall. Let's say a user wants to know, hey, I'm looking for, this product, do you have any matching product for that? It's doing a search on the search bar. Then how precise is the product that we are delivering to him? That is the precision metric. And the recall metric is like, are we providing all the products that are capable of meeting the customer's need? All of these metrics can be measured on the retrieval stage. On the ranking side, how closely are we aligned to the user's requirements? Are we matching it accurately? Are we giving him the perfect product as the first instance, or are we not giving him at the first instance? So we have a number of metrics there: success rate, mean reciprocal rank, normalized discounted cumulative gain. All these metrics can be used to look at how accurate we are able to deliver these ranking for the products that we are serving our customers. So besides measuring these metrics, we also have a number of strategies to improve these retrieval metrics. At the model level, we could be using the models really well. For example, the text embedding model, there are some levers available there like task type and title. If we can start using some of these parameters, we can start to very accurately build some embeddings that can deliver on, whether it's a retrieval augmented generation or various other types of tasks that we can use a text model for. Likewise, we can also tune these models. For example, if you want to tune the text embedding model, we can do that, and we have some some search adapters that we can build out for that. Besides the model as well as the search tuning, even on the input side, we can start looking at how are we chunking our input files. Whether it is, are we incorporating the right titles? Are we incorporating the right metadata? So there are a number of strategies again for the chunking. And we will not focus on this, but happy to share some of those links over to you so you can take a look at it. So besides the model as well as some of the strategies on the search side, we can look at improving on these metrics at an end-to-end architecture level. And what you're seeing here is what is called as a dual encoder architecture for embeddings. And you have two towers. You have one query tower and you have a database tower. And usually, both these towers are, neural network models. Sometimes these models are one and the same. Sometimes they are different. And what you're doing here is, you are training these neural networks with the same pair of, query and, response. And once you build out this neural network model, then it is able to create the embedding space for you. You can map these different database items to this embedding space. And then at the inference time, if you pass a query, then that embedding model is able to map this input query into that embedding space. And then you can use metrics like, cosine similarity or, dot product distance or Euclidean distance to determine which are your nearest neighbors and surface those candidates over to your application. Now, one of the innovation that we can do is also even think about the refining this architecture. Maybe if you have a different model for your database items, different model for your query, then you can certainly expand on this architecture and see how you can improve on the precision and recall metrics as well. So, we looked at various strategies on the model side, on the architecture side. We also looked at various tools. Now, continuing on that thread of, expanding, improving on the user experience, we will look into some of the other tools available within the Google ecosystem. So one of the tools we want to introduce here today is the Vertex AI Vector Search. Vertex AI Vector Search is a fast, scalable, and really economical vector database available on the Google Cloud. And in 2019, Google released a very seminal paper, this called as accelerating, large-scale inference with anisotropic vector quantization. And this paper really established a benchmark that bettered most of the state-of-the-art benchmarks on the nearest neighbor search. And that really paved the way for Google open sourcing that framework as a TensorFlow framework in 2020. And later in 2021, building on that, the Vertex matching engine was built. And it is definitely something that has helped in providing that low latency experience that our users wanted, providing that highly scalable, vector store that can hold millions, if not billions, of items for serving for our end customers. So all the developers out there, I would highly encourage you to consider vector search for your applications to expand on your user experience. And let's think about, how does this vector search work? And let's say you have your customer is looking for a shoe, and you have a catalog of 1 million items, and you want to kind of serve a matching product for your customer based on whatever communication they're providing. Either they might be uploading an image of the shoe that they currently have, or they may just be typing. And if you have to pull the corresponding matching item from your database, then one thing you can do is you can go and match it every item in your database with the item that the user has launched. And let's say if you have 1 million items, then you're looking at 1 million matches that you need to do. And that brute force method might be very time consuming, it might be very expensive, and it might also take a lot of effort. So an alternative approach could be what is called as the approximate search method. And what it does is it really breaks down this entire vector space into a few partitions. And then in these partitions, you also define some hashes so that, think of it like, the US postal map. You have the zip codes. If if it's a 1XXXX, it is probably the New England region. If anything that starts with a 9, that's probably in the West Coast. And let's say if it is something like 98, that it's probably the Seattle or the Oregon region. And that really allows you to go, as you go step digit by digit, you can narrow down which area we are talking, which particular region we are talking, and which particular locality we are talking. A similar strategy is applied here through this asymmetric hashing algorithm, through which you are able to very fastly get to the specific set of products that are matching your item. And that's how even though there are 1 million products in your catalog, you might be able to very quickly serve what your customers want at runtime. And that's very powerful for providing that experience to your customers. Besides the vector search, we also have other databases, vector databases on Google Cloud. We have AlloyDB and CloudSQL, both with PG vector extension. BigQuery also supports vector search. Definitely urge you to check out BigQuery's native text embedding solutions, which we talked about as we talked about the models. We also have a number of vector databases with open source roots, whether it is VB8, Pinecone, ChromaDB. You have access to all of those vector databases as well. So definitely urge you to check them out as well. So now what we did so far is to look at what embeddings are, how are embeddings used, and then what are the different orchestration mechanisms by which embeddings can be used in applications. We also looked at the models. We looked at the different metrics and the tools that we can use to generate and improve on the user experience. Now we'll gradually transition to a demo section, and we'll give you a quick demo of a particular solution that we have built for you to take a look. So the demo that we are going to walk through is a typical retail problem. Every retailer has about 1 million SKUs in their in the catalog, and they want to be able to fully define these product attributes. And as and when they are launching new products, they want to be able to take advantage of the catalog that they already have, and then specify these attributes for the new products. And why are these products attributes so important? Just imagine a user is going on to a retail website and he's typing in, "I want a shirt." Then you want to be able to identify the right attributes in the product so that you can specify that specific shirt that the user is looking for in front of the customer. Then your sale is done. So with that, the attribute becomes super important for retailers. So what we have done here is, take a product catalog from a top retailer, and we have run it through the multimodal embedding model, generated some embeddings, both text and image embeddings, loaded it onto a vector store like matching engine, and then this is resident and is available at any time at inference time. And on the other hand, at the inference time, a user walks in, he has a specifications. We are taking an example of a shirt, and we load the shirt into a multimodal embedding engine, the standard multimodal embedding engine on Google Cloud, generating the text and the image embedding vector, and then matching it using the matching engine, so that now we are able to retrieve the top 5 or top 10 products which are matching the product that we are going to launch. So once we have identified the top 5 or top 10 products, the next step is really extrapolating some of those attributes and attaching it to the new products. Now that's a significant productivity gain that will also accelerate the new product launches that we are thinking. That will also give a very good hierarchy that's appropriate for this product that we are launching. So that's what we are going to demonstrate. We have some code available. We can certainly share this after the call, or and now we'll turn it over to the demo. Excellent. So this is a Colab environment, and we will share the link for this Colab over to you, so you can run this through at your own pace. And what you're seeing here is the retail problem. It's the product attribute extraction problem that we just talked about, and it's typically for the retail world. It's also applicable in the consumer goods world. It's also applicable in manufacturing as well. If you're having a number of SKUs and you want to get attributes for those. So we'll be running it through a few steps. I mean, we'll be installing some dependencies, and then we'll be running some libraries for helper files, and then eventually we'll be building out a database of embeddings on BigQuery, and that will be available for the validation of this solution. So we'll move forward. So we'll first install all the dependencies. So the dependencies that we need for this particular demonstration are primarily the Cloud AI platform, and we'll also be using BigQuery and JSON Pickle open data sets. Let's go ahead and install these dependencies. And then the next step is we'll have to restart this kernel. Every time you install a library, you want to make sure you refresh on the prior library. So restarting the kernel is a good practice. And then you want to authenticate yourself. Whatever is your ID on Google Cloud, go ahead and authenticate yourself, and that will be available for you. We'll also be instantiating a few constants like the project, the location, the product table. So this will be very handy as we are trying to instantiate Vertex AI and loading into BigQuery. Now, as we talked about a few helper files, we'll be using the embeddings, the multimodal embeddings at 001, and a few helper files are available here. And the multimodal embedding at 001 gives two outputs. It's a text output as well as an image output. The single call will provide you both the two vectors. So go ahead and we'll probably run this as well, so that this helper file is available for us. Okay, so the next step is the BigQuery helper file. So we'll be creating a table on BigQuery. We'll also be uploading a data frame onto BigQuery. Go ahead and run this helper file as well. Even on cloud storage, we'll be storing some of the images on cloud storage. We'll be downloading those images from cloud storage. So we'll go ahead and run these helper files as well. We will be using Gemini Pro Vision in this demonstration. The reason why we are using Gemini Pro Vision is Gemini Pro Vision is natively multimodal. So if you give an image, it can give you a description. So we are going to be using Gemini Pro Vision, and within Gemini Pro Vision, we realized that we'll probably touch on this a little later as well. The description that the Gemini Pro Vision provides is really helpful in terms of describing it a lot more logically. It's not too technical, and that will be super important for us. A couple of callouts here. Sometimes if the image is not the right type, Gemini Pro might not give you a response. So you want to make sure you take care of some of those scenarios. Or likewise, if there is a toxicity filter violation, Gemini Pro might not give you a response. So just make sure you have those try-catch calls in your function call as well. The next step here is ingestion of the data set, and so we'll be using Kaggle's data set, and Kaggle ran a competition a few months back, where they shared a Flipkart data set. So we'll be using that data set. So I've already downloaded that data set, so I'm not going to run this cell, but it's available on the SPIM data cloud storage bucket. And if you are doing it on your own, yes, definitely go ahead and run this cell and get this data set loaded. Now we'll be loading. I'll be downloading this data set onto a local storage bucket, local storage on my Colab, and then I'll be loading it onto a data frame. So go ahead and run this cell, and we can load this into a data frame for use. Excellent. So the data set itself has about 20,000 records, so we'll be using them for our analysis. So next up, let's understand the columns here. That's the first step in any data science project. The data set currently has a few columns like the ID, the product name, the price, description, as well as image. So it's really very helpful to understand what columns you have and then plan for it. Now, this particular data set has a field called as description. So for our demonstration, we'll be focusing more on the description field. If we can publish a description for the new product that we will launch, then then that's pretty good. I mean, if we can extrapolate that same field for other fields as well. So let's go ahead and plan for the field description. The one thing you want to watch out here is if there are any special characters like /n. And if you're using a CSV method for uploading to BigQuery, you want to make sure you are replacing these /n's with some either a null character or some other character that is not violating, that doesn't lets the file straddle across multiple lines. So go ahead and replace this and execute that cell. Next up, we will understand the data quality. The data that we have received, as I was talking earlier, sometimes it may not be the right quality. You may want to take some tests to make sure that you're getting the right quality. So I just looked at the first record here, and I called Gemini as a description for this particular image, and you can see Gemini is giving a very functional response, whereas the original description is a lot more technical. There are words like the brand name. There is also a style code, and of course there is a lot of good content here. So you just want to make sure you're balancing the technical description versus the lot more functional description. And that's why you want to strategize that, okay, maybe I want to use a little bit of the functional description that Gemini is giving and a little bit of the original description. And part of the reason is also because the multimodal embedding model has a 32 token limit. So you want to make sure that you can balance out some of the text that you're receiving from the original description with the description that is a lot more functional that Gemini is giving. The Gemini response is about 31 tokens, and it's about 162 characters. So maybe we'll probably do 100 character of Gemini description, and then maybe the rest of the length we will use the original description. So that's going to be our strategy as we are planning to plan for providing the right text, so that as we do the similarity search, this text can also play a role for identifying this particular product. So with that in place, let's go ahead and get started with some data ingestion. The first step is ingesting this data, and we'll be creating a table and uploading this data frame into BigQuery. I've already done this, so I'm going to skip this step. But if this is the first time you're doing it, feel free to go create the table, upload this data frame into BigQuery, so that you have the data available on your own tenant. Next, we will be updating the BigQuery schema to store these embeddings. So we'll have to make a few changes to the schema. We'll have to add a couple of columns, like the text embedding column, the image embedding column. Let's go ahead and make this change to the schema, so that as we generate these embeddings, we can store them. Next up, let's get the data from BigQuery and let's load it into a data frame, so that we can do some processing. So I'm going to be using a data frame different from the original data frame, called as DF, where I'll be loading this input coming in from the BigQuery table and then storing it here. A couple of columns, as I mentioned before, there are about 20,000 records here, but we will not be using all the 20,000 records for our demo. We'll probably be using only about 100 records, because just for the speed of illustration. So we'll only use about 100 records, and we'll be showing that demo to you. Next, we'll go ahead and generate these embeddings. And for generating these embeddings, again, this one, even for 100 records, it could take a while. So we'll probably have to kind of, we have it already available, so we can show that to you. As I mentioned before, we will use a piece of the Gemini description and the functional and the technical description that is originally provided. So we will create something called an augmented description that uses 100 characters from the Gemini description, and the rest will be the original description. So now we have a better context around the image, and we can now invoke the embed method, generate these embeddings, and then write it into the BigQuery table. So yeah, I've already generated these embeddings for about 100 records. So we're going to skip this, and we're going to go to the next step. So a couple of callouts here. Sometimes if the images are not of the right type, you could again kind of run into some errors. So plan for those kind of try-catch error methods, so that you're able to gracefully exit, or you can plan for alternatives. You can plan a log, so that you can go back and correct these errors at a later time. Okay. So there are about 100 records here, and now some of these records, might not have good images, so you might actually have to skip some of them. Okay. The next step is, downloading the images. As part of the generation of the embedding, we also downloaded some images. We put it onto a cloud storage bucket, but having them locally really can be very helpful. So we are going to be we're going to run this, so that we can download these images locally. Next, we will need to publish these embeddings in a JSON format. We want to use vector store. And so the embeddings are available. Now we will generate these embeddings in a JSON format. So we'll run this command for us to be able to generate these embeddings. So there are about 91 embedding records here, and totally about 91 text embeddings and 91 image embeddings. So totally you will probably generate about 182 records. So we'll create it in a JSON format file and move this JSON format file into a cloud storage bucket. And that cloud storage bucket would be referenced as we create these indexes. So yeah, there are 94 images. Some of these images were probably 6 images were missing, 3 images not the right type, somewhere like WebP format. So that's where you lose out on some of those images. We need to go back and fix it. So we got 91 plus 91, 182 records. We'll store it in this cloud storage bucket called PIM embeddings. The next step is really building out this vector store. And for building out this vector store, we'll use the cosine distance as our distance measure type, and we'll be using this PIM embeddings as our embeddings URI, and then we'll create these embeddings. So the vector store itself has 3 steps in creating the vector store. Number 1, create the index, and number 2, create the index endpoint, and finally you want to deploy this index onto the endpoint. So what you're seeing here is on the console, you can actually see these indices and the endpoints. So you're seeing one endpoint, and I have several indices that are created. I've deployed the multiple indices onto the same endpoint. So you have that option of having multiple indices on the same endpoint as well. So we now, I already have this endpoint, so I'm going to skip this step, move on to the deployment of the index to the endpoint. And again, even deployment takes a little bit of time, so I'm going to even skip this step as well. But feel free to go ahead and execute this step for you to deploy this index onto the endpoint. So as you can see, I've already deployed about 7 indices, and this is the 8th index. Something to keep in mind. So one other point I want to stress on here is when you're deploying this endpoint, when you're creating this endpoint, whether it is public endpoint enabled or whether you want to keep it private, that will determine whether you want to have an VPC network attached for creation of this endpoint. If you want to keep it private, then the public endpoint enabled should be set as false, and then you have to attach a VPC network and create that endpoint. Now that we have the indexes created, we have the endpoint created, let's go ahead and see what all indices and endpoints are available. Now we have some commands that are here that you can run to look at these indices and endpoints. That is the endpoint ID. So we'll be using that endpoint ID for identifying that endpoint. So go ahead and store that in a constant. We'll also be calling this deployed index ID PIM endpoint index 7. We'll reuse an existing endpoint index for our demonstration purposes. So now we have an index endpoint created. I think at this point in time, we have the database tower created. The next step is really, the rubber meeting the road. I mean, we want to start using this endpoint, using the index that we have deployed, and looking at how we can, validate what we have done so far is working well or not. The first step, we'll visualize this vector space. We have about 20,000 records, but we have only taken about 100, and even out of 100, we're only going to visualize about 24 of them. So you can see there are various products in this catalog. You have water bottles, you have t-shirts, you have shoes, pendants, a wide variety of products here. It's a great combination of products that we can use to test out our solution. So the first thing that we will do is, we'll launch a product, and that product could be a t-shirt. And, I've already, identified that t-shirt. I have taken the image of the t-shirt from an internet. So we'll be using that as a, t-shirt launch image. And we're going to see if there are any matches available in our catalog. We know there are matches available. So we are going to kind of test this out. So we are able to generate both the Gemini description. We were also able to generate the original description. Just like before, we will strategize around 100 characters of the Gemini description, and then the rest would be the original description, so that we are able to also describe this product accurately. So when we do the vector match, it's also able to use the text descriptions to do the match and give some better candidates as well. So we will be launching this t-shirt. So now let's go ahead and generate the nearest neighbors for this test case 1. And you can see that the vector search has given us 7 products from the text embedding and 7 products from the image embedding. And also the distance measure for the matching products are shown on the side. So that tells you which products are probably much closer to the image that we are trying to compare against, the image and the text combination that we are trying to compare against. So you can see, I think the image is probably having a much smaller distance even to the text. but the text comes very close. So let's go ahead and visualize all the nearest neighbors for this product that we are launching. So you should probably see about 14 different images, and great. So what you see here is the first three are t-shirts, which is great. So which is matching very well with the product that we are launching. There are also other products coming up. So this is probably a thing of quality that you want to go back and measure and see. You can see how you can optimize this retrieval process. So this is very helpful, because now I can use the attributes from these new t-shirts for the product that I'm going to launch, and that's going to make the life of the merchandiser a lot more easier. So we'll now move on to the next test case, and this time we're going to launch a pendant. It's Valentine's Day, and it's time to think of a pendant. And we are going to be again picking up an image from the internet. We're going to be generating some embeddings for this pendant, and the original description is a very short description. And here is the image, and the Gemini description is a lot more functional, describes it very well, whereas the original description is a pretty short and concise description. So we can go ahead and combine these two as we look for nearest neighbors for this pendant. So let's go ahead and generate the nearest neighbors. And just like before, we have 7 text-based candidates and 7 image-based candidates. And again, I think the image-based candidates are trumping the text-based candidates. But the text is very close. I mean, some candidates are coming even through text as well. So let's now go ahead and visualize the nearest neighbors for this test case 2 and see how they look. So again, we will see about 7 images coming in from text, 7 images coming in from image, so a combination of the two. So great. I think what you see here are all really good pendants, and I can probably take one of them or the rank 1 and look at the attributes of this pendant. Then I can extract the fields from this pendant and attach it to the pendant that I'm going to launch. So again, that's going to make our lives a lot more easier as we are going to launch new products. So that's pretty much a demonstration of what we wanted to illustrate. So we were able to kind of take 2 examples, a t-shirt and a pendant. We were able to come up with the nearest neighbors among the catalog of products that we had, and we were able to get some nearest neighbors. And now I can use the attributes from these nearest neighbors to backfill the attributes for the new product that I'm going to launch. And this can be super helpful for me as I'm launching a product every week if I'm a big retailer, or at least every month if I am not a big retailer as well. So that's pretty much our demonstration. I'll now turn it over to Lauren for us to take us through the next few slides.
Amazing. Thank you both so much for this presentation, the content, and the demo. That was really great to see. And thank you all for joining us and for all of your questions. I know we are a little over on time, but we did want to make sure we were covering some of your questions. So we will transition there. If you have to drop, that's totally fine. You can check out the recording afterward, and we'll be sure to send it to everyone who signed up. Okay, so let's cover a few of these questions that we received in the chat, and then maybe we can cover 1 or 2 that we received that were pre-submitted. So first, we see this question from Sebastian. Would the embeddings also be capable to find similarities between multi-page documents, or is this more complex problem? For example, finding the similarity between one research paper and another.
Yes, I think, as you think about chunking strategies, you could plan for a full page, full document as a single chunk. Again, it also depends on the size of the paper itself. So certainly it is possible. And, planning your chunking strategy according to your inputs, you can certainly address this particular requirement. What do you think, Bob?
I think you addressed it, right? So you are looking at multiple documents, right? So you got to take individual documents and you got to chunk it, and you got to store it in a way, organize it in such a way that you are doing similarity between papers, right? You are You are embedding and putting it in the embedding space in such a way that you are doing similarity between papers and not what is inside the paper, right? So yes, it is possible. The workflow can look a little complex, but it is doable.
Yeah. If your paper is too long, you can also think of summarizing the paper and thereby comparing the summaries. So definitely there are various strategies that you can apply to see similarity between documents.
Great. Okay, thank you both. One here. When do you use the vector search versus AlloyDB, since AlloyDB can also do vector search?
That's an
So
excellent
this is an interesting question, right? It's so all the databases, not just AlloyDB, right? In the future, you're going to see all the databases are going to give you this capability of storing embeddings and doing vector searches, right? So when we talk about our matching engine from a Vertex perspective, we are talking about a service that Google is giving to you, right? So you will generate your embeddings and you will upload these embeddings into Google Cloud, right? And then you will kind of deploy an endpoint, right? You will create an index and you will deploy an endpoint in the cloud. This is all just one click, right? So you can bring your big enterprise data, and then just generate embeddings and upload it and use it as a service. So that's where you would see the Vertex platform and the Vertex service that we are providing you. From AlloyDB perspective, yes, if you are looking at Postgres, and if you're a big Postgres user, right, AlloyDB is basically Postgres on steroids, right? So it becomes very easy for you to integrate it with all your applications. You can do SQL, right? You can do SQL to do your searching, right? So that is what you're going to get with AlloyDB, right? So depending on what your use case is, you will either look at going and using a matching engine service that we are providing, or you will basically go back to the Postgres PG vector and integrate it with your applications.
Yeah, one other point I want to add here is, so AlloyDB is a structured database. So if you have, a lot more structured data that you want to combine with unstructured data, AlloyDB could be a great candidate. The vector search, if you're having, millions of items, performance is an important metric for you, then definitely when it's performance an important requirement, vector search could be a great option for you. So there are some, you definitely want to compare the capabilities, constraints for both these databases, choose the right one, but each one have their own strengths and certainly, take advantage of them.
Makes sense. Thanks for walking through that. Sounds like a good blog post that we could work on potentially. All right. So just two more, because I know we're over time, but I want to make sure we're getting to your questions. So this one here, what are the prerequisites, the must-haves or the nice-to-haves, considering resources, computational power for using embeddings for customer applications? This might be a big question, but maybe we can summarize it a little bit.
Yeah, there are definitely various components for using embeddings in custom applications. Think about the model, think about your vector search, vector database, and think about your end user, right? I mean, how do you want to deliver this application to your end user? And if your end users are going to be millions of users, then you definitely want to plan for that level of throughput and that level of ability to serve that kind of an audience, as well as if your database is like millions of SKUs or even billions of entries, you certainly want to think about scale in that side, whether it's a vector database, as well as as you think of creating the embeddings, there are some request per minute constraints for an API. So want to think for that as well and see how you can best deliver some of these solutions to your customers. Well, what do you think?
One more thing I would add is like Google is thinking about bringing Vertex extensions. So when you talk about customer applications, it might be a COTS application, right? It might be your ERP system. It might be Salesforce.com. It might be anything else that you're using ServiceNow, right? So we are working on coming out with Vertex extensions, which will kind of connect you to your applications that you have in your organization, right? What that means is that now you can bring semantic search to those applications, and you can bring embeddings and generate embeddings and kind of use it as an integration strategy, right? So what I would say is, like, most of the times you would find a place to store your embeddings. So make sure you have enough capacity, and depending on the size, you want to see, how you want to have your resources set, right? And then you're going to create a index, and you're going to deploy the index. That means you're deploying the index to a container. So make sure you have enough power when it comes to containers, and probably if you're using some kind of a GKE, then it gives you the scalability that you're looking at, right? From a developer perspective, definitely use the Vertex AI platform to do your ML ops. So right from building your model, doing some data engineering work as a pre-work for your models, and then deploying your productionized Gen AI applications, you're going to see that this unified platform is going to speed up the time to build and deploy.
Awesome. Makes sense. Okay. Hopefully these are relatively quick questions, but is text embedding Gecko 002 the same as the models embeddings 001 from the Google Gen AI list? And if this isn't, easy to answer, then we can always recommend the community. Maybe it's a better question for the community for us to get back to you. What are your thoughts?
Yeah, I have not used embeddings -001, so I really cannot comment on that, but certainly can come back to you on the question.
Perfect. So definitely recommend, we'll make a note of this, but please use the link in the YouTube description and you can create this question or search for the answer there. All right, last one for today. Is there a way to re-rank the documents retrieved on Vertex AI?
Maybe a different way to answer this question could be, is there a way to influence the ranking of the documents on Vertex AI? And yes, you could, there are a couple of strategies. There is something called a search adapter. We touched on it during our presentation. You can tune text embedding. You can, just like, you tune a foundation model, you can publish your query, your matching document and a score for it, so that your text embedding Gecko model can be tuned. And yes, it's available on Vertex AI, and that will automatically help you to improve the ranking. That will help you to improve the search accuracy as well as the recall as well. So definitely check out. Maybe we can share that link over to you, and that will help you to address this requirement.
Great. Yeah, and with that in mind, that's a good segue just to say that we will be adding the links to the resources that we covered in today's session to the original event page that you used to sign up. So no worries on relocating this. We'll send it out in an email to everyone who signed up in the recording, as well as add it into the YouTube description so you can access all those links and resources that the team covered on the presentation today. So with that in mind, just wrapping up here today, again, we mentioned the community. If you have any questions that we weren't able to get to today, please use that. And we'd love to stay in touch with you there. I also just dropped a feedback form. It should just take you like 30 seconds to fill that out. We would love to hear from you. If you want to take more time, provide suggestions for future topics, we really do take a look at that and value your feedback. And it really influences what we choose for upcoming sessions and topics and content. So really value your feedback there. And then lastly, just a few other upcoming sessions, one later today on coding with Duet AI. So I'd love to see you at that one or any of our future sessions. Thank you all for joining us. Any final thoughts from you, Bala and Guru? Thank you so much again for the content today.
Happy embedding.
Yeah, happy embedding, and try all the code that we shared in our presentation, and come back with any questions that you might have and how we could help you.
Love it. Happy embeddings, everyone. And I hope you have a good rest of your day, evening, or wherever you are in the world. And we hope to see you next time. Thanks again.
Thank you.